Hello everybody, this is kind of a new thing for me, so bear with me here. If this is your first time visiting the channel, welcome. If you are a return visitor, thank you for your support. In the previous episode, part 1 of the Atari Lynx 2 restoration project, you would have seen me fix up the power issues that we had with this PCB. Today I'll be walking through the install of the RetroSix CleanPower. That said, I'll get out of the way and we can get on with the video. So, I need to remove D11, D9, Q12, this diode, this, and this. Before using a hot air anywhere near plastic, I recommend using some Captain tape or even better aluminium foil tape just to protect it from being melted, which is what I'm doing here. Hot air is on about 400, which should be enough for this, I would say. I just want to sort of heat this area up here. In order to prevent thermal stress, which could damage the board, I am constantly moving the air gun around to try and heat the board in a uniform manner. As that occurs, the solder will heat up as well, and once the solder becomes nice and shiny, which is basically liquefied, then I come in with the tweezers and lift the component off. Well, that went reasonably well. Alright, I'm just going to clean up these pads now. And now it wants me to bridge from here to here on Q12. Got that bit done. The bridge is put in place, and I need to cut the trace at the start of the battery positive. As you can see in the clip, I've used a grinding pen to actually cut the trace here. My recommendation is just be really careful when you're doing this. You need to be fairly precise. Before moving on, I just thought I'd check that I cut the trace correctly. Continuity. Put that on here, and then go. Yeah. Yep. That's fine. Oh, it appears fine anyway. Using a multimeter, measure resistance between the battery ground or metal shield and the 5-volt rail, which is now on the left of the removed D9. If the resistance is lower than 50 ohms, you have a short. Okay, so I need to go sort of here and here. Oh yeah, that's fine. 34.6, yeah. 34.6 kilo ohms, and here 34.64 kilo ohms. That all appears good. So stick the green power on top of the shield or RAM if it's been removed. Well, I removed it, so I'm going to stick it on top of the RAM. Okay, that's good. Now, if using the stock DC jack, solder bat negative to bat negative. If you're using the UC, remove the bat negative wire. So I need to do that and remove the DC jack. Okay, so later on in the install process, I changed my mind and reinstalled the DC jack, mainly because I was having problems with getting good connections on the USB adapter. That's not a fault of the CleanPower, it was a problem with the traces on the board. I've left this in as it might prove interesting seeing how you remove these jacks, plus it highlights that nothing ever quite goes to plan. Good. Well, that worked. If you didn't remove that, solder the USB-C port in place. Move the jacks. Expose the copper below the ground pad so you can solder it to ground. So what you're about to see me do here is to grind away some of the protective cording that covers the PCB to expose the copper ground plate so that I can solder the USB adapter to the ground plate and ensure that we get good connectivity. Here is where I made a fundamental mistake when installing the USB-C adapter. I failed to take into account that pin 2 and 3, as you can see on the board at the moment, also need to be soldered to the adapter. In hindsight, this is what led to me having to take the USB-C adapter back off the board, and I decided at that point to reinstall the original jack. Again, here I'd like to emphasize that that has nothing to do with the quality of the CleanPower. It was simply my mistake. Yep, that's fine. Now that we have that done, we can get on with the last of it, which is, sorry about the lack of sound here. Unfortunately, I didn't realize that the mic was switched off. In order to complete the installation, there are 6 wires that need to be run from the CleanPower PCB to different points on the board. The first wire I ran was from the bat minus pad on the PCB to the negative terminal on the battery spring. Unfortunately, the camera work here wasn't particularly good. I was concentrating on what I was seeing through the microscope and not looking at the monitor. In order to save a little bit of time and probably some frustration on your part, I will fast forward through this section, but I will put the locations of the wires up on screen for you as we do that. In order to test this now, we should be able to plug this in to my bench power supply. Like so. Set this to 5 volts. And if everything goes right, I want to get it set to 1 amp. So, which is, should be safe. I should now just be able to apply that to there. And then go. So it doesn't need a game to plug in, so if I press down on that, we're not getting anything, are we?
Two hours later.
We have winner. Don't know if you can see that. Yeah, there. Yep. So I have power off, on, off. Yes. Okay, and if I switch it on, I'm seeing 0.2 of an amp draw. Yeah, dropping down to 0.164, 0.236. So that's looks like it's working. Okay. So that's how we install a CleanPower. So that's the first time I've ever installed one of these. I don't think it was an over arduous process. But I suppose we should hook it up and see if it'll actually load a game. Yeah, I think we only need to hook up the speaker to test that, to be honest. I don't even know if the speaker works in this thing. I'll just put that like that. See if I can move that over there. Put that onto there. Like that. Put that there and then switch that on. Oh, I heard it crack. I heard a crackle. see what happens when I put a game in it. Yes! Got something. Yes, that looks like it's working. Brilliant. That is really good. Okay, switch that off, unplug that, and I think I'll call that a do.